So we got another talk here, a tech talk that is part of WeAreDevelopers Live. We are happy to have Marco Podian here from Algorand Foundation. And you're going to tell us all about blockchain, aren't you?
Yes, also how easy it is to get started and where we stand in the hype cycle.
Excellent. So I'm over to you, Marco. Thank you very much for being here.
Thank you for having me. So let's dive right into it. Once my clicker works. Okay, so my name is Marco. I work for the Algorand Foundation for about like 14 months now, something like this. I've been spending more than 20 years as a developer in general, built a lot of e-commerce systems, and then was gradually transitioning into the crypto world. But I like to think of myself that I still stand with one foot in the Web 2 world. So I understand myself as an interpreter between the Web 2.0 and the Web 3 world. So basically, what is blockchain? And I want to talk to you about building real things, like real world problems that blockchain technology is actually very well suited to address. So let's start with like a little bit of a story about how blockchain can actually provide humanitarian help, value where value is needed. And what we see here is a scene from a market somewhere in Afghanistan. And in Afghanistan, we have a couple of things that require us to be a little bit more creative in terms of technologies that we apply for achieving value exchange between people. Because what some of us might actually take as given, using your phones, your credit cards, whatever, even cash, paying with things, might not be as easy in other parts of the world. I chose Afghanistan here as an example for a couple of specific situations that we have there, and also because we have one project that I will dig into later that is out in Afghanistan running on the Algorand blockchain to address these shortcomings. And one of these shortcomings, for example, is that in Afghanistan, we do have a shortage of cash. So there isn't even enough physical cash in the country to address the daily need, the daily supply needed to exchange the value that we have. We have, I think it was 6% of the Afghani population having access to the banking system in the first place. So that's already like a very, very small number. And of those 6%, women are actually like vastly underrepresented. And we can address all of those things with blockchain technology. And there's this project called HisabPay that actually does that. So when you have an app, access to a mobile network, which is like kind of ubiquitous around the world, or just like having access to certain values through something like a QR code, you are basically capable of putting up a payment network, exchanging values between visitors of the market, merchants on the market, and like all of these things. So essentially, based on blockchain technology, you can build a payment network everywhere where other technologies are not present, and you can build this in a very fast fashion. I think originally it was designed as a pop-up payment network for disaster regions, something like that. So you can also imagine this like being able to allow for value exchange in regions that have been hit by some kind of catastrophe and you need to build up something fast. So, and having talked about what you can actually do with that, I would like to have a look into what blockchain technology actually is. And then I want to talk about a couple of specific things, why you would choose Algorand as your blockchain solution of choice, and a couple of additional real-world scenarios. Like I talked on the show earlier with Chris about how people try to show how cool they are when they do live coding. I will do some live coding to actually show how cool other people are that build some of the things that I want to show you, just to give you an impression how easy it is to start with blockchain technology, starting experimenting and evaluating with them with basically no barrier whatsoever. So we start with blockchain. And blockchain, we perceive ourselves as an industry basically as the next evolution of the internet, or like blockchain as an infrastructure layer for the next evolution of the internet. We remember there was Web 1.0. Actually, I gave a talk the other day at some conference about AI agents, and most people there did not know who Tim Berners-Lee is. So if you happen to not know who Sir Tim Berners-Lee is, please look that up. If you are a web developer or interested in the web, you basically use his technologies every day. Actually, everyone out there uses his technologies every day. So the first iteration of the web was some pure lookup thing. It was a catalog of things, was like originally invented for scientific literature, cross-linking, thus the links we have nowadays on the internet. And it was basically just to look up information. Then we had the .com bubble. .com bubble brought us like additional technologies. Then we had mobile technologies, and all of those like culminated in something that we nowadays call Web 2.0. And that is basically where the consumer of the web turned into, we called it at the university, the prosumer. So they added content by themselves, and we had the age of big platforms. And platforms come with a couple of downsides. So like discrimination mechanisms, everything is basically gated. We have a lot of walled gardens. We have a lot of financial interest behind those things, and it's not always the easiest collaboration between those. And as a user, you sometimes get into the crossfire that you would like to move things across platforms. Not always as easy, and a couple of other downsides. And there comes the third iteration actually of the internet as we as an industry perceive it, which is basically the web where you can have a share of what is happening, share of the value unlock, and you're also being put back into the driver's seat of owning your own data. So there are like plenty of aspects. There's a good book that digs into the basics of this, which is actually called Read Write Own, I think by Richard Dixon from A16Z, something like that. Please look that up. And that gives you a rough overview of like where we stand there. And we think that blockchain is actually the infrastructure layer that allows you to operate this value sharing Web3 approach. And the blockchain itself is basically a decentralized, tamper-proof digital ledger, transactions grouped into secure and linked blocks. That means you have like a ledger, a register of transactions that is append-only, and you have a number of people in the hundreds of thousands that have a copy of this ledger. And every one of those copies is composed of blocks. So you have those transactions that are append only, and they are grouped into blocks, and those are cryptographically linked. Thus the term blockchain. And since we have like a lot of copies around the world from hopefully independent parties, we with vested interest in having the network as such being healthy, we have basically a temper evident way of showing that someone's copy has not been altered with. They could try to manipulate stuff, would become like very evident if people try to compare their copies. And then every blockchain has a mechanism of consensus. Those mechanisms are usually very different across blockchains, how the next block should look like. So there's a group of people having copies of this chain of blocks locally, and then they come somehow together, usually to check how the next block should look like, which transactions should go into this block. That's the basic principle. And generally, to some degree, hopefully to a very high degree, those networks are decentralized. So you also hear the word decentralized technologies a lot. So there's no central party that could discriminate like anything what is happening in there. And the communication in the network to varying degrees in many blockchains is also decentralized. So it's basically a permissionless thing. And usually you also speak of a trustless system. So everyone can participate, and you don't have to trust the other parties because you can always verify everything that's happening on-chain. On-chain, of course, like the term that we use for the operations that, or the data that is actually like in those blocks of transactions. And that's essentially it in a nutshell, a 2-minute explanation of what blockchain actually does. And some of the key use cases that we identified, and I think those were also discussed, I think, last year at the WeAreDevelopers conference, are disintermediation. So like taking out the middleman. You can basically write code that runs on the blockchain somehow. We will have a look briefly into that a bit later, where you can then show that things can happen without the platform being like the regulator in the middle and holding the hand open just to take some money. So this could be done in many cases fairly easily. We have data integrity, so you can, as I said, validate every time you want to look something up and you don't trust the other party, so everything is immutable. It's always there's always a state of truth that you can always check. And the market access, that's like a perfect example is this HesabPay project, where basically everyone can participate, no mechanism of discrimination, and the technological barriers are actually also very low to participate in that. So and then we mentioned, where do we actually stand as an industry somewhere in the Gartner hype cycle? So the Gartner hype cycle basically is this curve, and most technologies nowadays to some degree follow this curve, where you have the peak of inflated expectations. So everyone screams like, yeah, this technology is awesome, and this will solve all of our problem. And then people find out maybe it does, but it doesn't do it to the extent that we actually would like it to have. So we basically drop into this trough of disillusionment, and everyone is like, oh no, no one needs this. We should never talk about this technology again. But of course, this is all just like broader public perception that is happening there. And then slowly, technologies mature, and we reach the what's called the plateau of productivity, where we have mature technologies that can be actually used to solve real world problems. So basically the topic that I want to talk to you here about. We have a couple of technologies. Don't worry if you have to zoom in to read that later. Those are a bit oldish numbers, but I wanted to like show that to show you we are sure, or we agree that the crypto industry, the blockchain industry as a whole, is composed of a lot of different technologies, and many of them have made it past the hype peak. So we're not that popular anymore. People talked a lot about the things that go wrong in the industry, but we are actually slowly building real-world applications that deliver actual value, like monetary value, humanitarian value, like you name it. And for most of the technologies you see here, I would actually say that we are past the trough of disillusionment. And for some of these technologies, and I will get back to a couple of examples, we actually approaching very rapidly now the plateau of productivity. So there's a bunch of things that will unlock value very soon, and in my opinion, to an unexpected degree. But I will get back to these examples when we reach them. So why would you choose Algorand as your blockchain solution? Like the marketing blurb is that Algorand is an energy-efficient, quantum-secure, single-layer blockchain with instant finality, consistently high throughput, low fees, and it's been operating at 100% uptime since it went live 6 years ago. We can dig into all of this. So we are energy efficient. I think we offset enough so that we are carbon negative. We are quantum secure. So the history of the chain is quantum secure. So we are like safe for the quantum computers that are coming. Not all of the aspects, but like the history of the chain. We are a single layer blockchain. Some of you might have heard of layer 2s. So basically like another abstraction layer on top of a blockchain. We addressed many of the layer 1 shortcomings so that we do not have the need for a layer 2. We have something that's called instant finality. So on many blockchains, you basically have to wait additional time for confirmation that your transaction actually made it through. We have a block time, it's called, like every time a new block is created, of just under 3 seconds. And once those 3 seconds are passed, you can be sure that your transaction made it into the block or not. If it didn't, it will also, in contrast to other chains, not incur any fees. Then we have consistently high throughput. I think the theoretical max that we did not reach, I think, like at least not naturally, is about 10,000 transactions per second. That's pretty high, and we have low fees. So the minimum is 0.001 algo, and we basically never have network traffic that would spike this minimum fee. And given the current algo price, this should be less than half a cent actually as transaction cost. And we are one of the few blockchains that have been live for 6 years now without any outage. That is also something that I hope is reassuring for people. So here, a couple of those numbers again, the transaction throughput that we have, the block time with the instant finality that I mentioned. We have more or less constant transaction fees of this minuscule amount. We have this instant finality. We never had any forks. We never had downtime. As of this point in time, in May 14th, 2025, we have more than 50 million blocks, more than 3 billion transactions, and almost 2.5 million monthly active users. And as a technological platform, Algorand basically gives you a lot of things that you might have to build yourself out of the box, and that already takes a lot of the pain out of developing not only a decentralized application. Those are the applications usually that we talk about when we look at things that talk to the blockchain, but generally for any application, those can take some of the headache out. So we have functionalities that take care of accounts, account creation. Basically, it's based on a public key infrastructure. We have functionality that allows you to transact, like sending payments. It can be done in a very simple way. We will see an example in code about that in a couple of minutes. We have automatic checks that transactions are actually valid. So all of those things are baked into the technology platform. We have the possibility to create tokens. And when I say tokens, this could be crypto coins, something like that. Don't challenge me on the terminology there. So basically everything that you can have where you can spend fractions of stuff. So we talk about fungible tokens. And then there's this other term that you might have heard probably more frequently, which is non-fungible tokens. So basically tokens that you cannot just freely exchange because they represent something unique per token. NFTs, you remember overpriced JPEGs. That might still be kind of interesting for some people because you can see them as collectibles. But you can also see those in other contexts. I think Starbucks had until recently actually their reward point program in NFTs, and basically everything that you can imagine as some kind of token, you can easily, as a feature of the blockchain itself, with just an API call against the blockchain node, create there. We will also see a very, very solid trend in terms of real-world asset tokenization. I will get back into that topic, and I will show you how easy it actually is to get started with those tokens. And as I said, those fungible and non-fungible tokens, technically you can almost treat as the same when it's about managing them. Then smart contracts is probably something that some people might have heard, some people might not have heard. This is basically a self-executing piece of code where an agreed upon set of rules is executed when certain conditions are met. So that's the name, right? It's a contract between a number of parties, and the rules written in that contract are enforced when conditions are met. Like when the parties come and provide a monetary exchange, something like that, and everyone put their signatures to their respective transactions. So I want to give you X token, you give me A token in exchange, and the smart contract can enforce rules around that. And those rules can be literally anything. I will show you an example that is super straightforward. It's a hello world indeed, that will give you a very quick glimpse into how familiar those things already look like because of some things that we put a lot of work into as the Algorand Foundation and the Algorand ecosystem. And that is a set of tooling that we call collectively AlgoKit. And AlgoKit comes with a CLI tool that wraps a number of other CLI tools that basically gives you all of the operations that you need to communicate, collaborate with the chain itself. we have the Puya compiler. That's a very nifty piece of technology. So the code that runs on the blockchain for us, on the AVM, the Algorand virtual machine, is written in a language called TEAL, Transaction Execution Approval Language. And that language reads a little bit like assembly code. So it's basically like a very straightforward and execution efficient stack machine. And the Puya compiler now takes higher level languages, and for us, those are Python and TypeScript, and both of them syntactically and semantically correct. So not like Python or like TypeScript, but the actual languages that is compatible with the tooling that you're already familiar with. And the Puya compiler takes those two languages and breaks them into an abstract syntax tree and translates them to the TEAL language, so that with the language that is admittedly very hard to read, for me at least. I have colleagues that actually can fluently read and write that. I cannot. You have those higher level languages. And as we saw from the success model of the web, higher level languages just like eat the cake when it comes to like broad adoption of those technologies. And this is like what we hope for in the end. So we build all these things to give you another tool in your toolbox. And I hope I can convince you to at least give it a chance and try to experiment with it. Then part of AlgoKit is also something that we call utils. And, naming is hard, right? There are like two big problems in computer science: naming things, cache invalidation, and off by one errors. And utils are basically our SDKs. Like the background to that is SDK, the terminology was already taken for a couple of things actually in our ecosystem. So for the time being, those are called utils. And they basically wrap per language everything that you need to communicate with the blockchain, with a couple of components surrounding the blockchain itself. I will dig into a couple of them. And calling your smart contracts, actually, something we will also get back to very briefly. That will be the clients, which we have this client generator for. We have a couple of other things in there. And the last one is here that you can actually do step debugging, something that you might be used to from whatever programming language you are using. And it's a very powerful tool. I think I will not have time to demonstrate this because I'm also not properly set up for that. But I can assure you this works. And if you are interested, you can contact us and we will happily demonstrate this to you. And with this, I actually want to show you like how easy this is to get started. And I want to do that live in code. As I said, not to show how cool I am, but how cool the things are that people build for Algorand. So we are in some directory, and there's this tool called AlgoKit, right? And we can check what version of AlgoKit we have. That should be the latest version. And we can now say, AlgoKit. First of all, I will check that my local development environment that is Docker-based is running. So you might see, no, you don't see on my screen, I think, that I have my Docker daemon running, Docker desktop, and I will say AlgoKit localnet start. And this will give me the status of a bunch of containers. Some of those containers have names like AlgoD, which is basically your local blockchain. So this is one node. You are the only node in this blockchain, but this is like in this configuration enough. So you have your local copy of the blockchain. And AlgoD gives you a bunch of API endpoints to operate against. Then all the data it needs is stored in a Postgres database. And we have other Docker containers, for example, for the indexer, which is like literally doing what it says. It gets all the transactions that are coming through the chain and basically indexes them in a way that you can search over them basically in any dimension that you can like think of. So that's essentially it. It gives you an easy way of searching everything in there. So everything is running properly, and we will do a simple, of course, you should not say that, but in this case, I hope getting started should be fairly straightforward. So we have an AlgoKit init. This is where your blockchain journey starts, given you have installed the AlgoKit tool, of course. I do that usually with pipx. I think there are other ways in the documentation, but once this is done, this is where it starts. It will prompt you for a couple of inputs. So it will ask you if you want to build a smart contract, a dApp front end that basically says it's a front end application that talks to something on a decentralized network, aka blockchain. Thus the D for decentralized. We can do a combination of both. And I will choose the smart contract because this is what I primarily want to show you here. And as mentioned, we have those two higher level languages, Python and TypeScript, and I will randomly choose Python here. And we will give the project name. I will call this WeAreDevelopers Live Day, and then it will create everything we need from a template. It will ask us about the name for our first smart contract, because that is the central piece of our smart contract project, right? We will pick the default, and we will say that we want to do a production grade one. It has a couple more things that you might need when you move from your development phase to your deployment phase and then your production phase. Then it will ask you for the language for the deployment. We will stay with Python, and it will ask you if you want to do a bootstrapping, so installing all the dependencies. I think we can afford doing that. Most of the stuff should be cached. You see here we are using Poetry. Poetry, one of the I would say standard Python dependency development mechanisms, like next to pip, conda, UV, super powerful, is what I use in other Python projects here. Then it asks us if you want to do the first commit, and I would just say yes. So it really doesn't matter for me at this point. Then we can actually change into the WeAreDevelopers live directory, and we see that we have a bunch of files here. And of course, we want to have like a deeper look into them. So we want to open cursor. Yes, I'm a cursor guy. Please convince me otherwise. And we will have a look how this looks like. One of the first things that you will notice is this pop-up message that pops up here that asks you to open the project in a workspace. That's just to organize the files better. So essentially, this means that we have in our root directory this file here called WeAreDelive code-workspace, and this just splits out our project structure according to a monorepo approach. So we have like a lot of sub-repositories in our project here, and we want to treat them as if they would be different repositories, although they are not. And we do that through this file, and then we see we have the WAD live directory here, which is basically like the smart contract bit. And if we had front-end application or other smart contract or additional front-end applications, or any number of projects in there, those would all be their own directories there. So just that you don't get confused. And when we are in this directory, you will find this directory here called smart contracts, and in there, the hello world or whatever name we picked for our first smart contract. In here, we have contract.py, and if you just give it like a very quick glance, what is happening here, I am very, very confident that you actually can tell me right away what this code does. Can I give you 2 seconds? Yes, it can be that easy. So this is your very first Python-based smart contract on Algorand. And it's like that easy to get started. There's a shortcut here, pressing F5 to execute a bunch of steps that we need in order to deploy this on our local blockchain. And we can see here in the end, after a couple of seconds, that it creates a bunch of things. And in the end, it prints hello world for us. So what happened here now? So first, we built the code, like we talked about this teal language. And in this artifact directory here, we do have the teal code for like a couple of things. And we do have additional files, which is Puya. Puya terminology, you also heard earlier, does basically like a mapping file for this abstract syntax tree-based compiling language that we talked about. And we have this arg56 JSON, for example. And this arg56 JSON is a description of how you can communicate with a smart contract that we just defined. And this can be translated into some kind of interface, a user interface. We will briefly brush on this in a second. And it's also used to create a client application. So we have the Hello World client here. And this is basically like a client that allows you to communicate with indexer that's wrapped in there, the algo dnode that's wrapped in there. So communicating with the blockchain. And it also gives you out-of-the-box functionality actually to call different kinds of functionality from your smart contract. So you can directly call the hello method or whatever other methods that you might have defined in there. And that is essentially it. So it runs and you have everything you need. If we now want to have a look what actually happened there. So we executed actually this deploy config, and we can see here that we threw in, let me remove this, that we threw in world as the name. So if we now, just to demonstrate this, manipulate this to say actually world 1, 2, 3, and then we do the whole F5 thing again, then we should see in the end that it will tell us hello world 1, 2, 3 after everything is properly executed. Here, just to give you a better idea that I did not do some monkey business here, I think the saying goes. And if we now want to learn more what actually happened here, because we created something that we threw against the blockchain, we can type AlgoKit explore, and this will open for us in the wrong browser something that is called LoRa, the Explorer. And that is our live on-chain resource analyzer. And I hope that at least one person was laughing at LoRa, the Explorer, because that's what I always need. Thank you very much, that one person. And that is your block explorer, as we basically say across the industry, that allows you to dig into everything that happened on the blockchain. So we are here on localnet. You remember, I did AlgoKit localnet start. So this is my local copy of the blockchain. You can also point this against any other network like testnet, which is a public test infrastructure, or you can directly talk to mainnet, like the production ready infrastructure. And we want to have a look what happened last on our local copy of the blockchain. So you remember we executed hello world 1, 2, 3. That should be the latest transaction in there. And when we look in here, then we can see that we have a lock. And when we decode this from base 64, we see hello world 1, 2, 3. And this is exactly the transaction that we just used to call the smart contract, because calling a smart contract is a transaction. We call it an application call transactions. There's a number of other transaction types that you can learn about in one of our workshops. I will get back to that briefly towards the end. And you see all the parties involved, like who called it, where did the call go to? So this was application ID 1002 with that associated address. And my local default account was basically like this one here. We can also check in there. So I basically have a little bit of algo, which is like the local governance token, also the currency that you pay transaction fees in. And you can see that I didn't clear my environment for a while, so there was a little bit of stuff happening. We have this concept of minimum balance. So when you create things like applications, tokens, or something like this, you don't have to, apart from the transaction fee, to create and manage those things, you have to lock up a tiny little bit of your algo. So 0.1 algo for those things, and also 0.1 algo for an account that is online, basically, like that can transact. But as you remember, or you can probably look it up whenever you watch this recording, the value of the algo might vary a bit, but those 0.2 algo is usually like a tiny amount that in most scenarios you can afford, I would assume. If not, let's talk. That is essentially it. You're a blockchain developer. So I'm done here. I can go home. But there's one more thing. Actually, there are a couple more things. So for the last couple of minutes that we have left, I want to show you a couple more examples how those things can actually look. And everything starts with an AlgoKit in it. And I wanted to talk to you about a couple of those real world use cases. We have more examples if you want to like dig deeper into that. We have like payments, we have tokenized things, to be honest. So you can tokenize gold, you can tokenize real estate, you can tokenize basically everything, intellectual property, you name it. So you can take any kind of like asset, and you can, or like specifically, or more interestingly, any kind of illiquid asset, and you can tokenize on chain, and like just like that, turning it into a very liquid asset that you can then like do all sorts of things with. We have supply chain traceability. That is a big topic since the inception of blockchain itself. So like a public tamper-proof infrastructure is actually very interesting for use cases where you have to like have provable or like auditable records of your supply chain. We have data integrity use cases, payment we will look into, and we already mentioned, and yeah, any number of use cases that I am probably lacking the fantasy to like elaborate here at this moment. So let's talk again about HesabPay. Like for me, one of the most interesting use cases that we have there. Not only because it's like technologically very interesting, because it shows like with how little effort you can actually create like a payment network. Many of the participants in payment networks nowadays actually play roles and charge fees for services that might have added value, but might not necessarily be an essential part of a payment network. So this is a fantastic example of that. So we have this public infrastructure, the blockchain, and we saw that we can build transactions, and that's essentially most of what you need. Of course, HesabPay does a lot of extra stuff on top of the Algorand blockchain as the infrastructure layer, and that is like something I want to like reiterate. We ourselves think of us as an infrastructure provider, and here is a personal opinion piece that eventually people, or like consumers at least, end consumers, should not necessarily know or have to bother themselves with what kind of infrastructure a given project is actually using. Of course, there are like a lot of use cases like centering around self-custody, where you would have to like know and be in control with whatever kind of wallet you are using to decide yourself what is happening with the data that you move around, or the value that you move around. But there are a lot of projects where this isn't of no concern of the end consumer. So it should step into the background. I think it's a quote from Arthur C. Clarke that any mature technology is disappearing. Think of electricity. You don't think about what's necessary to go into electricity, right? You just know it comes out of the wall. And you just press a button and it just works. And when you go to some kind of website, when you go to your favorite social media app, you don't give it another thought what kind of database technology or queue system or whatever cloud is running in the background. It's just not important. And I think, my personal opinion, that this is the way that blockchain will also go. So this is a very important infrastructural component that will eventually like be fulfilling the use cases it's built for, but will just be taken as a given. And in HesabPay, we have this infrastructure component, and of course, and like the people from that project actually can tell you a lot more about that. They built it in a way that it's easily accessible through smartphone apps. Like vendors can use those smartphone apps, customers can use those smartphone apps. Sometimes when there's no device available, you can also have like QR codes that represent a certain chunk of value, so that like in any scenario, you can easily distribute the value to the people who need it, and then they can exchange this and like basically instantly create like an economy where there was none before for whatever reason. And to give you a very simplified version of what is actually happening there, of course, is like a lot more complex. I brought you a couple of code examples, and those are a couple of the things I mentioned earlier. So here, for example, we have the creation of a client itself. So during development, it's very easy to set everything up following the default conventions. So you don't have to take care too much when you go with standard use cases. And I think that's at least an 80-20 thing, that this is enough for most development use cases, where you basically have one line and you have a complete configuration with your default account that does things on there and all these things. We can create accounts when we, for development reasons, don't care what this account is. We can create any random account, so like a public-private key pair. There's a couple of other things like a mnemonic involved, but I don't want to go too deep into the details here. And we can, from the sender, get the address that is like the wallet address, and then we can do things with that. So here we have the Python example, and just this one slide in TypeScript to show you that this is like basically the same. Like syntax is a bit different, how you annotate things is a bit different, but otherwise those two languages are on feature parity. Then you can send a payment. Just as easy as this one call here. You put a bunch of parameters. You have a sender, receiver, and the amount. We have like a value object around the amount to also make that easy. And that is basically it. This is how you do a very simple example of a payment. In a more realistic scenario, there would be like a couple of signatures required here, of course, but that's essentially it to get you started. And then you can verify the payment. We talked about this indexer that allows you to like search through all of this stuff, and you basically search a transaction by like any criteria that you imagine there, and that is it essentially, or like that is it. You can get started. Another interesting project is Lofty. They do luxury real estate tokenization in the US, fully tax compliant, I think. And basically, you take this luxury real estate, you put this on chain. I mentioned the term real world asset tokenization. So you basically take the value, the ownership, put this on chain, and then you slice this into many, many small pieces. You tokenize it, and you can then sell off some or maybe all of those slices, and someone can like buy those, and then they're actually eligible to receive monthly rent payments according to however many pieces of this estate they bought. Also sounds like a very simple principle. In principle, it is actually very simple. I'm sure there's a lot of regulatory stuff behind that, but the idea of tokenizing essentially everything is as straightforward as it gets. And to show you how easy this can be in code, you can create an asset with a simple call against the Algorand node with the Algorand client, put a couple of parameters. Some of them here are even like optional, and that is essentially it. So we create like a luxury property, like 1 to 3 Main Street share. We give this like a unit price. It has a total number of 1,000 units, 0 decimals, because you can also go like very fine-grained on the decimals here. Maybe the Bitcoiners have heard of Satoshis. And that's essentially it. You created something tokenized on the chain. Then smart contracts, something I don't want to talk too much about here, but also those are very easy to write in Python and TypeScript. And we have a whole workshop. I will put a QR code in a second to that, where you can subscribe. You can participate in TypeScript or Python every month. And when you are not available in the time slots, just sign up and you can watch the recording later. And I just want to show you like how easy this is. We can like provide a bunch of state here, and then we can create a method basically that is called an ABI method. So it's publicly available, that allows us to execute this from the outside, send transactions in there, like with payments, with other things, and it can send inner transactions by itself, so it can call other smart contracts, and it's basically self-executing code. Like it's a contract that knows what to do under what circumstances. Then last week we had the WeAreDevelopers World Congress in Berlin. By the way, hi, I'm Berliner. If you happen to be in Berlin as well, chat me up. And my colleague Brian gave a talk about 402 payment required. There's the QR code on screen of the recording of this talk. So if you're interested in that, because we think that this might be a very, very big thing that is coming, which is HTTP-based payments. This will be a huge thing across the board, like human-to-human, AI-to-AI, agent-to-agent payments. And the book is not written yet. So there's like a lot of work to be done, but there's also an opportunity to participate in that. Watch the talk, come talk to us. And yeah, a fantastic opportunity to dip your toes into decentralized technologies while also like already looking forward to the next trend technologies. And I am like very sure that what we see with stable coins at the moment, if you have heard that term, that's going to be a very, very big thing, especially in context with like web-based payments of any kind of flavor. I can also like greatly elaborate why I think that's the case. I think that is like all I wanted to tell you today about. Like I generally wanted to give you an idea how easy it is to get started. So honestly, if you ask me, I've been there. There's like not much barrier to actually just start trying the decentralized technologies. It's like literally AlgoKit in it, waiting 2 minutes for dependencies to be installed, and you are good to go. And then when you want to learn more, like this QR code will lead you to the sign up page for these workshops. It's a 4-hour workshop that you will get out the other end with like all the knowledge to get you started to actually building something bigger. If you like prefer self-studying, algorand.co/algokit is a good entry point to all the material that we have. Documentation, of course, we have under dev.algorand.co. If you want to talk to people who are already working on, with, and in the ecosystem of Algorand, Discord is a fantastic channel for that. Basically, everything we do at the Algorand Foundation is open source. If you're interested in like collaborating there, go to github.com/Algorand Foundation and maybe give us a quick follow at X with under the Algo Foundation, or maybe shameless plug here because I had an oopsie with my original Twitter account. If you want to be among my first 100 followers on my new account, it will be lazystar.algo, and you will make me very, very happy.
Very cool. I mean, this was so cool. I changed my shirt for it. So yeah, so I guess there's not much questions for me to left because you covered everything, and I love that you ended up with the course and everything, so people can take a look further there. Quick question: Are you looking for more people at Algorand as well? Are you interested in people contributing? What's going on there?
We are always looking for people contributing, of course. That's like one of the reasons why you go to open source. We are specifically looking for at least that's how I perceive my role. We are looking for Web 2 developers who are curious about how crypto technology actually works. So we are looking into expanding the Algoverse, that's not an official term, our ecosystem. And rumor has it that we might look for someone in DevRel, but this is not official information.
Excellent. Well, anything from yours end, Danny, or shall we just give Marco his time to get some food as well?
Yeah, I think we'll give Marco the time. I mean, just from my side, though, I think what's really good about this is that we talked before about some of the criticisms of blockchain being that people don't understand it, they can't see the real world use, and I think it's really nice to I feel like we're at the tipping point though, where the work that Algorand is doing, the Algorand Foundation, is so much about real world examples. And
yep.
Chris, we even talked last week, didn't we, about the potential use of kind of people keeping ownership over their own content when it's being ingested and indexed by LLMs. So I'm sure we're going to have you back to hear a lot more about those real world applications. And it was great to see the insights. Yeah, thank you so much.
Thanks very much, Marco, and have a lovely day.